Hi, I'm Vin, a statistician at Reverse Science, and I'm very excited to introduce to you a six-part video series on the concept of statistical power. You might have heard about power in the context of whether a study have enough power or how to use statistical power to determine the number of sample size that goes into a study. Well, in this six-course video, we'll begin with the very basics and we'll build upon the core concepts that leads up into our sixth video and talk about statistical power. So without further ado, let's begin on our first video where we'll discuss about the null and the alternative hypothesis in hypotheses testing. Thank you, and we hope you enjoy. Hello, and welcome to the first video in our statistical power series. So in this first session, I'll try to provide a quick and intuitive explanation of the null and the alternative hypotheses that is often used in hypothesis testing. So the first step in hypothesis testing is to state the hypotheses in its null and its alternative forms. The null hypothesis, denoted as H sub 0, is essentially a statement of no difference. For example, say we have a treatment for an illness and we want to figure out whether this treatment works for the subjects that we recruited with the underlying symptoms. So that's trying to cure. So we conduct our tests. We have we set up a test group and a placebo group in which we give the test group our treatment and the placebo group a placebo. And then we're trying to find out whether our treatment worked or it has a significant effect. So we collect the data, and now we're ready to do some statistics. So the first thing you want to set up, right, is the null hypothesis, which is going to say that there is no difference, and then the alternative hypothesis, H sub A, is the opposite. It contradicts the null hypothesis, and it's going to say that yes, there is a difference. So then the researcher usually seeks evidence against the null hypothesis as a way of bolstering or strengthening the alternative hypothesis. So let's look at a simple illustrative example to make better sense of this. Excuse my little drawing here, but this is historical data. Let's say we have this made up historical data of body weight from men ranging from age 25 to 35, and they're from the 1990s. Right, and say that this data gives us a mean weight of 170, right? And the standard deviation is, say, 40 pounds. Now, our test, we can say that have the weight of these men in this age group, 25 to 35, has an increase from the 1990. So here we go out, we collect our surveys, and we get our data, and we calculate some mean for the current population of X and some standard deviation of Y. Now we can use this data to compare it back to our historical data and see if the weight has actually increased. So now under the null hypothesis, which remember is a statement of no difference, so then we state that there is no difference in the mean body weight between the 1990s and now. So let's provide some labels with that to make sense of this, and we'll let mu represent the current population mean, right? So this is the current population mean that we just collected of our body weight in 2021 here. So if mu represents the current population mean, and the null hypothesis is that there is no difference between the body weight between 1990 and the current population body weight, then it would be mu is equal to 170 pounds, right? There's no difference. And then alternative hypothesis would be the opposite. It would say that the mean weight has increased. So then intuitively we can think of mu is sorry, let me erase that real quick. It's not going to be equal to, it's actually going to be greater, right? Greater than 170. So then our H sub A, will be mu is greater than 170. So what we state here is actually called a one-sided scenario. So let me just write that down real quick. So this is a one-sided scenario, right? And what this means is that we're only looking at values greater than the hypothesized population mean. We're looking at the deviation only on one direction. But we can actually consider something called a two-sided alternative hypothesis, where that looks at both the higher and the lower than expected population mean. So for this case, mu would be not equal to 170, and our two-sided alternative hypothesis, right, would be mu equals not equals 170. So yeah, just be aware that this two-sided scenario of alternative hypothesis does exist, but we'll focus on this one-sided example. So one thing to note here is that the null and the alternative hypothesis are set up in a way so that one or the other must be true and the other must be false. And another important thing to note is that the alternative hypothesis is closely aligned with your research hypothesis. Remember, the objective of our test here is to seek evidence against the null hypothesis as a way of bolstering the alternative hypothesis. And if the alternative hypothesis align with your research hypothesis, you're also bolstering and strengthening your research hypothesis. In the next video, we'll continue with this example, but we'll talk more about the actual test statistics. Thank you.